Okay, you're given the coordinates of the endpoints of the transverse axis for a hyperbola and the length of the conjugate axis. It has to come up with the equation of that hyperbola. One of the first things you want to do is to locate the transverse axis in the center of the hyperbola. So if you plot the vertices, here's 1, 5 and 1, 1, the transverse axis passes through the vertices. So it's a vertical line, which means the hyperbola opens up and down. The conjugate axis, oh, by the way, A is the distance from the center to a vertex, and the center is the midpoint of the segment joining the vertices. So here, this is A equals 2. And the conjugate axis is kind of like this segment right here. It's perpendicular to the transverse axis, passes through the center, and its length is given as 6. So that means this portion, the distance from the center to a co-vertex, it's called, is 3. And that means B is 3. There we go. Okay. And sketching that little green center rectangle, and then the asymptotes passing through the center and the corners of that rectangle helps you sketch the hyperbola. So again, it passes through the vertex, and then as x gets bigger and bigger, the y values get closer and closer to that asymptote. And here's the other side of that branch. Not a very good sketch. And here's the other branch. Now it turns out there's two other points that might be of interest, and that is, oh, by the way, if this is A and this is B, the slope of the line passing through this point in the center is A over B. For left and right opening hyperbolas, the slope of that asymptote is B over A instead of A over B. Okay, and the foci, the equation you want to use for the foci is that C squared equals A squared plus B squared. And so C, in this case, C squared equals A squared is 4, B squared is 9, so C equals the square root of 13. And that number, square root of 13, is the distance from the vertex to a focus. So square root of 13 is between 3 and 4 somewhere. So 1, 2, 3, from the center to a focus is square root of 13. So here's the center. 1, 2, 3. We can't go up 4, so it's right in here somewhere. That's a focus. And the other focus is down 3, a little over 3, 1 from the center. 1, 2, 3, and a little bit. There's the other focus. And if I put a point on the hyperbola, I wanted to go to green, and draw the line segments to each focus, and call that distance D1 and D2, for example, D sub 1, D sub 2. That distance, or the difference between those distances, is a constant, and it's actually 2 times A. If you picture this point lying at one of the vertices, that helps you visualize why it's 2A. Okay. And by the way, there's the equation of the asymptotes. There's the slope, A over B, negative A over B. And then the center is at 1, 3. And here's what that looks like With a full-blown sketch, there's the equation. The center is at 1, 3. A is 2, so this is a squared. B is 3, so that's 3 squared. And, if you let x equal 1, do you see what happens? If x is 1, for this equation, this term disappears. And if you multiply both sides by 4, you get this. If you take the square root of both sides, and then add 3, that means the y-coordinate when x is 1 is either 5 or 1. There's the vertices. Okay, so visualizing where the vertices are helps you decide whether to put the term with y first or the term with x first. Okay, there you go. Hope that helped. If you have any questions, post a comment.